Hi all, I'm Meenakshi. So now we'll see example for merge sort. So that is an example for divide and conquer technique. So here is small example where we have numbers 832971154. So initially it has to be splitted into two parts, and again recursion, again two parts here, until we get array with one element only. Here it is 832 etc. So now recursion call goes back to merging the solutions. So whenever we have array with element 1, that itself is a solution which is already sorted, and next it has to be merged, that is 3 and 8. And here in the another part, 2 and 9 will be merged to 2 and 9 in the increasing order, and again it is merged here 2 3 8 9. So parallelly it's happening to the remaining parts of the problems. So finally we are getting the merged sorted solutions here, 1 2 3 4 5 7 8 9, which is already sorted. This is a scenario of merge sort, divide and conquer technique. We will see the code for this. Textbook reference is Anane Levitin. So here is a code for that. Merge sort array A 0 to n minus 1. So what it does, it takes the input, and by recursive merge sort it will sort it. Output is sorted array in the non-decreasing order, that is increasing order. Okay. So if n is greater than 1, in the sense like number of elements in the array should be greater than 1, in that case you copy the first part, left part of the original array to B. That is nothing but we are going to split the array. If you see the example here, first we need to split first half to the array B and second part to the array C. Here this is original array A, and first left part is A B array, and to the right second partition is called array C. Similarly here in the code we are splitting. Copy the first left portion to B and second portion to the C, and you call merge sort independently for first half B array and second half array C. Okay, this is recursion. Recursively it will happen as long as the split or partition will have only one array. And here when it comes out, you need to merge B and C into A. A is our final answer, which it should be sorted one. So B and C, which is nothing but partitions, should be merged into A array in such way that it should be in the increasing order. We will see what's happening here in the merge sort. So merge sort is nothing but whatever we split here, we keep continuing this one as long as element will become 1. It should go back to merging the solutions. So merge code is here. So merge sort, recursion, and how merge is happening. These two split every time in every iteration, how it is getting merged. We will see that code. Code is here. So merge input is two partitions, that is unsorted B array and unsorted C array. And finally we need the sorted array A. So let us take two pointers I and j pointing to our unsorted array B and C respectively. Okay, B and C unsorted, which is to be sorted now, and pointers I is pointing to B and pointer j is pointing to C, and K is a pointer for unsorted array or the final solution A, where we want to keep the sorted elements one by one. So here if you take this example here, for example 8 and 3 here, you can see the pointer I is pointing to 8, pointer j is pointing to 3, and we are comparing. If we need in the increasing order, so that means here 8 and 3 is compared each other. 8 is greater than 3. So if you want in the increasing order, we need to bring the element from second partition, that is array C. So 3 is brought here, and increment the pointer, no more elements, it will come out. So that means to say whatever left out here in left part should be brought to the final solution, that is 3 and 8 is sorted. Similarly 2 and 9 sorted to 2 and 9 here, no changes because 2 is lesser than 9. If you see carefully here, 3, 8, 2, 9, let us take quickly here. So 3, 8, 2 and 9. So pointer I is pointing to this, J is pointing to this, right? So this is our array B and this is C to be sorted. So should be brought to final array A. Okay, so I is pointing to 3 and J is pointing to 2. Comparison of B of I and C of J, that is 3 compared with the 2. 3 is greater. So that means whatever the smaller element should be brought to A. So that is nothing but this 2 goes to solution. Fine. Increment J. Don't do anything to I because I did not take the element from array B. So increment J, that is J is pointing to 9 here, I is pointing to 3. Comparison between 3 and 9. 3 is smaller than 9, that means I want this element. You bring this 3 here. This is the final solution, sub-problem solution. So 2 and 3. So because I brought the element from B, you need to increment I here. I will be pointing to this now. Okay, so I is pointing to 8 and J is pointing to 9. 8 is smaller than 9. That means 8 should be brought to solution. So increment here, no more elements, it will stop this loop. That means you come to the second partition C, whatever remaining elements here, no need to have comparison. All the elements should be brought from C to final solution. So if any, for example here, if array C, we will take another instance. For example, here B is 3 and 8 and C is for example 2, 9, 10, 23. If I have this case, so 3 and 2 comparison, smaller element come here and increment here. 3 and 9, again 3 is smaller, come here, increment here. 8 and 9, 8 should be brought here and no more elements here. I will come out of the loop here. That means B array completely solved. So whatever there in the remaining element should be brought as it is because it was a partially sorted in the previous iteration. This will be sorted array. So that same thing shown in this code. So I loop, J loop, comparison between B and C, and incrementing I if you brought the element from A, incrementing J if you are bringing the elements from second partition C, and whatever it may be from B or C, A should be incremented further, the solution array K. Okay, and finally if I is reaching the end, means no more elements in B, bring everything from C to A, otherwise you bring everything from B to A. So that is we are checking the end of the loop here. So finally we are getting the sorted array.